Hello guys, this is Mr. Varela, and this is a lecture video on how to do the following worksheets. This is for my 8th grade students, my chemistry students only. If you're in 7th grade, there is no need to watch this video. Your assignment this week, this is going to be week number 3, I believe. It's going to be on COVID-19 and the science behind flattening the curve. Okay, so you're doing COVID-19 stuff. My 8th graders are doing this chemistry. Now, before we begin, just so that you know that these worksheets are available on my Google Classroom, you do not have to print them. There is a way around it. The first two worksheets that you print out are these right here. It says periodic table of valence electrons, and there's 2 pages. I wrote up here, this is for reference only. You do not need to take a picture of this and turn it in. This is for you. This is to help you to do the worksheets. Without this, you could use your science textbook. You could use your SMB because we talked about it, but I figured it would be nice to have this ready for you. Now, if you don't print it, that's fine. You could use your laptop or you could use your cell phone and download the documents and look at that document on your phone or laptop as you do the worksheets. Now, for the worksheets, however, you do have to download them. There are 3 worksheets that are available to download. Some of them have multiple pages. The first one is this one. All classes have to do this worksheet, periods 4 and 5, and it's just 1 page. There's no back, okay? It's just this right here. It gives you an example, and then there's other problems you have to do. The second worksheet, also all classes have to do, okay? Here's the problem. I'm going to show you how to work this out. I'm only going to show you how to do one, and you have to do all problems in order to get that 2% grade bump. Now, the third worksheet is for my pre-AP class, period 4. You have to do this one as well, along with the other 2 worksheets in order for you to qualify for your 2% grade bump. There is no partial credit for this week's assignments. Either you do it completely or you don't. If you do it completely, and when I look at it, it show that you did effort. Even if you get a couple wrong, that's fine. But if you're like way off, I can't give you credit. But if you tried your best, and I can see that there was some effort and you got the majority of the questions correct, you may qualify for a 2% grade bump. That means, for example, if you're getting an 88% in my class, that's a B+. You're not going to get 2 points. You're going to get 2 percentage points. You're going to go from 88% to 90. So you're going to go from a B+ to A- just by doing this week's assignments. Now, this week's assignments, because they're a little bit difficult, I have this video and I'm going to go over 1 problem on each worksheet to help you, but that's it. If you would like additional help, you need to attend my office hours on Tuesday and Thursday from 8:30 to 9:30. The office hours this week is really dedicated for my 8th graders. My 7th graders might pop in with a quick question, but I'm devoting the majority of my time to go over problems. You could tell me which problem you have, and I could write it down on like a virtual whiteboard on Zoom, and we could work out the problem. So if 1 problem as an example is not enough, I could go over a few more until you learn how to get it. Now, I mentioned earlier that you had to have these printed. The reason why you have to have them printed is because there is no way to turn this into Google Classroom. There's no multiple choice or, like writing an essay. You need to actually show the work and then take a picture of this handout or a scan and email it to me. My email is on my Google Classroom. However, some of you might not have a printer. Or if you're like, my family, we have a printer, we just don't have ink, because every time we drop 30 bucks for ink, it's empty in about a week and a half, and it gets a little tiresome. So I feel your pain. If you do not want to print this, okay, and even though you have other options, I know that FedEx office is open. Some students have told me that their parents, they could print it up at their work. There's some places that they still offer printing services. Like I said, FedEx office, I believe Staples is also open. But if you don't want to print it, that's fine. What you need to do is you have to get a blank piece of paper, or you could use lined paper. Lined paper is fine. And you are going to have to copy this down. I mean, just the title. You don't have to copy this part down, but copy the title so I know which worksheet you're doing. And then write out the question and then do the problem. For some of these, it's not much writing. I mean, that's not a lot of writing right there. And this isn't a lot of writing. A simple little title, and that's easy to copy. The trickiest one might be this one right here, but it's very short. Okay? So if you don't have access to a printer, you could just, write it out yourself. But I need to see the picture of it. I have to see the work. Okay. All right. So without further ado, let's begin. Now, these, like I said, these are your reference papers that you will need, or you don't really need them. You could use your textbook, you could use your notes, but I have it here available on Google Classroom, and it's a lot easier if you have these worksheets. What the worksheets do is they help you determining the valence electrons. Now, before we had to shut down the school, we were learning about valence electrons. Basically, valence electrons are the electrons that are unique in that they are the electrons that are always on the outside energy level. We learned that electrons float around an atom, but they float around in like layers, almost like an onion. There's an inner layer, and then there's another layer, and depending on how many electrons, there could be multiple layers. Now, whatever electrons on the outermost layer, we call them the valence electrons. And those are the most important ones of all because they're the ones in charge of bonding. It doesn't matter if you have 1 electron or 50 electrons. It's how many how many of those are valence. And the magic number that we're always trying to get, it's the octet rule. Okay, octet means 8. That's what oct means. Like an octopus has 8 tentacles. If you follow UFC fighting, if you follow MMA, the octagon, where the fighters, where they battle it out with their opponent, the fighting ring is called the octagon because it has an octagon shape. It actually has 8 sides, so they call it an octagon. So octet, oct means 8. Well, all of the elements, they want to have 8 valence electrons, but sometimes they don't. This paper right here tells you basically what is the octet rule. First of all, well, not the octet rule, but there's a shortcut. First of all, know that each of these columns are called groups. So this is group 1, this is group 2. I'm going to write it out here. This would be group 1, this is group 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one I'm going to have to write it over. This is 13, 14, 15, 16, 17, and 18. Okay? Now, this is a shortcut that by looking at the group number, it tells you how many electrons are available. So, for example, column number 1, group 1, is 1 electron. Group 1, 1 electron. And group 2 has 2 electrons. Now, these right here, these transition metals, they don't really count in our shortcut. Neither do the lanthanides or the actinides. And that's a problem with shortcuts. Shortcuts don't always work. If shortcuts always worked, then it wouldn't be called a shortcut, it would be called the rule. Okay, follow this rule. However, sometimes when we have rules, like in chemistry, there's easier ways to remember, but they're not perfect. And we call them shortcuts, where you could find a solution quicker most of the time. And in this shortcut only works for group 1 and group 2, and then any of these from group 13 to 18. The transition metals, it won't work, or the lanthanides or the actinides. And here's what the shortcut says, that if we keep going, when we're in group number 13, okay, remember this is 1, 2, then 3, 4, 5, blah, 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 11, 12, 13. Group 13 actually has 3 valence electrons. 14, this is a 14th column, has 4. Group 15 has 5, 16, 6, group 17, 7, and then group 18 has a full octet. Okay? Now, the other handout that's available, it's the same thing. The only difference is that it now has like the hydrogen, lithium, so it has all of the symbols. This one, if you notice, the boxes were blank. Okay, I included this one because of this information right here, so you could read it. Okay. Also, something very important I want to bring up, that even though octet, the name implies 8, when it comes down to hydrogen and helium, they don't need 8. In fact, they can't fit 8. For example, for helium, He, it only needs 2. It gets full right away because I told you that there's multiple layers of the valence electrons, or of the electrons. The very first layer only fits 2. So it fills up awfully quick. Doesn't need 8 because it doesn't fit 8, it only fits 2. So once it has 2, it's full, and then when you go to the next layers, you need 8. The next layer, you need 8. Next layer after they need 8. But the very first layer is 2. So hydrogen, H, has 1, but it would get full if it had 2. Helium already has 2. This is why helium and all of these noble gases, they don't combine with any other chemical. For example, helium has 2, it's already full. It doesn't need to hook up with anyone else because it already has 2. All the other ones have 8, they already have their octet, so they don't have to hook up with each other. So if we look at this periodic table, it shows you the symbols and all the valence electrons. And if you look at the bottom periodic table, it's the same thing, but it actually shows you the dots. Now some of these dots are written differently. Like for example, the way that we write, if we look at nitrogen. Nitrogen, for example, here's nitrogen. Nitrogen is group 5. It should have 5. And the way you draw 5 valence electrons, you start with 1 dot. This dot represents a valence electron. We start off at the 12 o'clock position. If it was like a clock, we go clockwise. That's 1, that's 2, that's 3, that's 4, but we need 5. Every room is full, so now we put the 5th one here and we stop because we only needed nitrogen right here. We only needed 5. So we put 2 dots on the top, 1, 1, 1, like that. That's how nitrogen looks like. And it shows you right here as a reference. We look at, let's look at chlorine. Chlorine is in group 17. So it means if it's group 17, it's got 7 valence electrons, okay? So here's chlorine, and it's draw 7. 1, 2, 3, 4, 5, 6, 7, okay? Now, if you look at the picture, they drew the picture differently. I ran out of room already here. They drew chlorine like this. They drew 2 dots here, 2 dots on the left, 2 on the bottom, 1. That's fine. It's the same thing. It's 7 valence electron. You know, this one's full, 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 and 1 is half, you know, full. That's fine. The rule of drawing it and going clockwise is only just like when we do the work. That way we kind of have similar work, makes it easier to grade. But technically, this is 2 different ways to write chlorine. Even though this is more universally accepted, this is still acceptable anyways. Okay. Also notice that the transition metals don't have anything. If you want to know how many valence electrons are here, you need to look it up. Okay. Same thing with the lanthanides and the actinides. Don't use a shortcut for these. A shortcut only works for group 1, group 2, group 13 has 3, 14 has 4, 15 5, 16 6, 17 has 7, group 18 has 8, except helium. Helium only has, that's right, 2. Okay? So you could use this paper as reference, or if you don't want to download it, you can use your phone. Let's get started with the work. Here is the first handout. Please take this one out. There's already an example here to show you. Basically, what's the big deal about valence electrons? Well, valence electrons will tell you, like here we have carbon, and carbon has 4 valence electrons. 1, 2, 3, 4. What valence electrons help you determine is who is carbon going to hook up with. Because carbon would like to have a full octet. Remember, octet is the rule of 8. Carbon doesn't have 8. It wants 8, but it doesn't have it. So by looking at the valence electrons, it can help us determine which chemicals, for example, carbon cannot hook up with, say, for example, fluorine. Fluorine has 7. 7 plus 4 is 11. 11 is not 8. So carbon and fluorine, for example, and chlorine, and all of those, they're not going to hook up. Not like that, not directly, because they're not fulfilling their job of getting an 8. So the valence electrons help us determine who gets to hook up with who. So here's what's happening. Carbon has 4, if it wants 8. Luckily, carbon is surrounded by all these hydrogens that have 1. What hydrogen is going to do, it's going to move its electron over. And this one is going to move it here. And this one's going to move it here. And this one's going to move it here. Basically, these 4 hydrogen are going to move to carbon. And what we end up getting is a carbon that had 1, 2, 3, 4. But then when hydrogen comes in and it brings its valence electron, now there's 2 right there. They're paired up. And when another hydrogen hooks up, it brings its valence electron. And then when a third hydrogen goes, it brings its single electron. And when a 4th hydrogen comes up, and check that out, carbon now has 8. 2, 4, 6, 8. The rule of 8. Now, hydrogen is also happy because hydrogen now has 2. And remember, when we look at this periodic table, you could read from all the mess that I made, hydrogen and helium, they don't need 8 to fill their valence electrons. They don't really follow the octet rule. 8 is too much. Think of hydrogen and helium like little kids. And they get full. If you have a little brother, like a 2-year-old brother, they could eat like 1/3 of a cheeseburger and get stuffed. Their stomachs are tiny. They fill up a lot quicker. You know, you might be able to eat a couple of Whoppers and still want more food because you're bigger. However, hydrogen and helium, they're like little kids. They don't require many valence electrons to fill up. They only need 2. Hydrogen, once it has 2, it has a full outer shell. So if you look over here, hydrogen is happy. It's got its 2. This hydrogen has 2. That hydrogen has 2. You get the idea. And carbon is surrounded by 8. Everyone's happy. Everyone got their full valence electrons. So use this example for the next 2 problems. Okay? I'm going to skip ahead to the 3rd one right here. It's a little bit complicated. Now, one thing you want to look for is the fact that they kind of give you the answer right here. This one right here, there's a couple of N's and there's a whole bunch of H's. Now, when they come together, they make this, hydrazine. Hydrazine is N2H4, 2 nitrogen and 4 hydrogen. Okay? Now, if you look at this one right here, carbon, we know from the answer, we put carbon in the middle. It kind of makes sense. Carbon has the most valence electrons, has 4, and it's surrounded by like its little minions. You know, he's like the leader. You need to determine, well, what goes in the middle? Does the nitrogen go in the middle or the hydrogen? Well, look for the element that has the most valence electrons. They're the ones that are going to be the centerpiece. They're going to be like the leader. Now, we have 2 nitrogen. So let's bring them both together. Okay? So I'm going to put the answer right here. You know what? Let me fold this down. No, that's a bad idea. I'll try to write it here. Hopefully I don't run out of room. Let's bring the nitrogens together. By the way, I'm using a Sharpie. That way you can see it on video. I recorded this video earlier and I used a pen and I had to record the whole thing over because it's horrible. I'm using a Sharpie, that way it comes out on the camera a lot easier. Please use a pencil, only because you can use a pen if you want, but if you make a mistake, white it out. But chemistry is like mathematics. You do it with pencil and you have an eraser because you will make mistakes, okay? Even Einstein made mistakes, okay? Erase your mistakes if you make it, but if you use a pen, then you're gonna have to white it out or print up another paper. Okay, so let's put the nitrogens in the middle. I'm gonna put nitrogen here, and I'm gonna put the dots. There's 5. 1, 2, 3, 4, and 5. Now let me put the other nitrogen here, right next to him. 1, 2, 3. Oops, I should have went 1, 2, my bad, but 2 on the top, 1 here, and then 1 here. Now notice that the dots on the side hook up together, so we got 2 dots in between. So we got 2 dots on the top, and now we got 2 dots between them, because one of these dots belong to this nitrogen, and one of the dots belong to the other nitrogen, okay? So far so good. I mean, we're closely getting an octet around there. Now it's time to bring in the hydrogen. There's a problem. We could put a hydrogen here because there's a space right there. So we could put 1 hydrogen there. We could put another hydrogen there and another one and another one. That's 4. But if you count, there's 1, 2, 3, 4, 5. What? Why is there 5 hydrogens? Well, they're trying to throw you off. They're trying to trick you. If you look at the answer, hydrazine, it says N2H4. It literally is telling you you only need 4 of these. Now, why would they put 5 hydrogen? Well, you don't always use your ingredients. Think of it this way. Let's say you're baking a cake, and your cake recipe requires 3 eggs. Well, you go to the store. They don't sell 3 eggs. They sell a dozen. Well, you buy the dozen eggs. Does that mean you're going to use all 12 eggs? No. You're going to take 3 of the eggs, use them for your recipe, and you're going to have 9 eggs left over. It's perfectly fine. You can use the eggs for some other time. Maybe you want to make an omelet. Here, think of these as eggs. We have 1, 2, 3, 4, 5, but the recipe only requires 4. So just use your 4. Let's bring one of the hydrogens here and put the dot from the hydrogen right there. Let's bring another hydrogen. And I know the dot is on the side, but it doesn't matter. You can put the dot on the top, on the right, on the bottom. So I'm going to put another hydrogen here and then put just 1 dot. Only 1 because it only had 1 dot. All right, what about this one? This one's empty as well. I mean, well, half empty. There's already one valence electron. Let's bring another hydrogen and put the dot right there. And right here, let's finish it off, hydrogen, and right there. There you go. That is hydrazine. Notice that the nitrogen is surrounded by the valence electrons. In fact, let me rewrite it a little bit nicer. So we have N. We have N. This N has 2 valence electrons on the top, 2 on the side, 2 on the bottom, 2 on the left. This one has 2 on the top, 2 on the right, 2 on the bottom. And notice that it's sharing these electrons. So if you look at it, this nitrogen has 8 valence electrons, has a full octet. And when I cover this one has 8. Yes, I know that it's like, well, how come you're not covering this one? See, I covered it like that. You see 8, and I covered it like that. I never covered these because these valence electrons are being shared, and that's okay. Sharing is caring. By sharing these valence electrons, both nitrogens have the full octet. But let's not forget our hydrogen. We have a hydrogen here. We have a hydrogen here, hydrogen here, and hydrogen here. And the hydrogens have, this one has 2. This hydrogen has 2. That hydrogen has 2, and this hydrogen has 2. And that's what we want, because remember I told you hydrogen is happy with 2. Okay, so that is how hydrazine looks like. Okay, it's 2 nitrogens in the center, and then they're flanked by hydrogen on the side, and then 2 on the bottom. And there you go, hydrazine. Okay, so for the rest of the problems, look at the answer that they're written out. Like for this one, all of these N's and H's. Well, what if you had nitrogen N2 and hydrogen H2? They're not combined. This plus sign means that you have 2 different chemicals. You have nitrogen on one side, nitrogen gas, and hydrogen gas. They're not combined. But if you have like this, like H2O2, that's hydrogen peroxide. Hydrogen peroxide is combined like this or together. Okay, if you have any problems, see me during office hours, okay? Next handout. This is going to be, I have a little mess right here. There we go. Here you are. Okay, take out this paper right here. We are going to do the first one. Okay, I believe there was there is a practice one. Well, it's not really practice. There's an answer key. I believe I included that one. If I'm not mistaken, I think I included this one, and there's a blank one. And I think I also included the answer. Okay. But even if I don't have it on my Google Classroom, I'm going to go over a couple of practice problems, and I could go over this during office hours. But here's the answer key for like a couple of practice problems that I believe I included in Google Classroom. I included it like this. You see, so yeah, I included it like this, with no answers, and then with the answers right here. Okay. If not, now's your chance to take a screenshot. If you're looking at this, let me put it up right there so you can see that. Take a screenshot. Here's the question, and here's how to do the work, and here's the answer. Okay, let me go over one problem. Okay, so covalent bonding. You will need this handout to do this problem. Okay, so let's say that we have CH4. Okay, that's methane, and we want to see how does it combine. Well, we're going to need 1 carbon, so I'm going to draw carbon. I'm going to draw 4 hydrogen. 1, 2, 3, 4. Now, using this as reference, I see that hydrogen has 1 valence electron. Look at the picture, it has 1. So each hydrogen, I'm going to draw 1 dot representing 1 valence electron. Now here we have carbon. Carbon is right here. Group number 14, therefore it's got 4 valence electrons. And if you look at the drawing right here, it's got 1, 2, 3, 4. Carbon looks like this, 1, 2, 3, 4. Okay, so how do we bring these together? Well, it's kind of like the last paper that we did. It's kind of like this one, except this time you are drawing this right here. In fact, I thought that looked familiar. Kind of looks like this one right here. In fact, it is that one. So what we're going to do is we're going to bring them together, and we're going to put each of the valence electrons, we're going to fill in these gaps. And what we end up with is C, and then we have 1, 2, 3, 4, and then like this H comes here, puts a second dot. This H comes here, second dot. Is H right here, that H right there. There we go. Now for the answer, what we need to do is whenever you see 2 dots in between 2 elements, The way that we draw it is like a line, okay? So I'm going to rewrite it. I'm going to put the C, but instead of 2 dots, I'm going to put that line, okay? And instead of these 2 dots, I'm going to put a line. This is how we draw bonding, and we're going to get to that next week, okay? These lines represent bonds. Now, sometimes you have single bonds. Sometimes you can even have a double bond. It looks like an equal sign. And sometimes you can even have triple bonds, which are the strongest of all. These are single bonds holding the carbon with the hydrogen. So what we do is we turn these dots into the lines. So this is your final answer, okay? So here you're showing the work, and this is technically this problem all over again, but now I want you to draw the actual bond. So because technically that was already a practice problem, I just realized that right now. Let's do this one, bonus one, you're welcome. Nitrogen and 3 oxygen. So here's nitrogen, and then O, O, O. Let's look at this one. Nitrogen is right here, okay? Group number 15. See, nitrogen, so 5 valence electrons. So nitrogen has 1, 2, 3, 4, 5. Oxygen, oops, on the other hand, oxygen is here. Oxygen is group 16. So it's got 6 valence electrons. So it goes 1, 2, 3, 4, 5, 6. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So for this one, the idea is how are we going to hook up the nitrogen and the 3 oxygens? Well, what we're going to do is we are going to see where they could fit it. I mean, if you look at nitrogen, for example, nitrogen is surrounded by valence electrons, but not completely. There's 2 on the top, but there's a space here, and a space right here. So what we're going to do is we're going to put nitrogen, okay, right there, and we're going to draw the 2 dots on the top, dot on the right, dot on the bottom, dot on the left. Then we're going to draw this oxygen right here, okay? So what we're going to do is we're going to put oxygen right here, and we're going to draw the dots. 2 on the top, 2 on the left, 1 on the bottom, 1 on the side, okay? Now, right here on the bottom, we are going to put the other oxygen, okay? We're going to put the 2 dots that start off here because we have room. 2 dots here, and 2 dots on the bottom, then 1 dot, then 1 dot, okay? Now, 3rd oxygen goes here. Same thing. We got 6, so we're going to draw 2 here. 1, 2, and then 3, 4, 5, and 6. Okay, now we have a slight little problem. And the problem is that nitrogen has its full octet. However, oxygen doesn't. In fact, oxygen only has 2, 4, 6, 7. Okay? What's happening right here is that the entire nitrogen oxide, actually not nitrogen, I need to look that up. The nitrogen oxide would be NO. It's going to carry a charge because it doesn't have a full octet around the 8, but the nitrogen is happy. The nitrogen has its octet. That's what it needs. Okay? So when we write the bonds right here, we are going to put N in the middle. Okay? And then see the O's right here, a line right here, a line right there, and a line right there. Okay? That's what NO3 looks like. These lines right here. Now, if you're wondering, well, what happened to these dots? How come we didn't put a line? It's not connected to anything. Same thing with these. Whenever the double valence electrons are between 2 elements, we put a line to represent a bond. Okay? All right. If you are in honors, we are going to continue to the 3rd video. And the 3rd video is, I'm sorry, the third handout. The 3rd handout is going to be this one right here. Okay, this one is a little bit more challenging. Basically, it's because you're going to show the electrons moving, but you're also going to have to show, this is actually going to be covalent bonding. Sorry, little brain fart right there. Because what you're having is you're going to have, ionic bonding. Because you're going to have ions. You're going to have a positive ion and a negative ion. And in this case, remember what we learned in class. Whenever you gain an electron, electrons are negative. So whenever you get electrons, you get more negative. And whenever you lose electrons, well, it actually becomes positive. Okay? Here's why. Notice that potassium, the K only has 1 valence electron. And chlorine has 7. So it needs 1 more electron. Because it's getting more electrons, getting more negative, it becomes negative. Now, why is it that when you lose something, it becomes positive? It's because an electron is negative. And when you lose something, that's negative value. You have $5 and you lose $5, it's -5. And negative times a negative is a positive. So when you lose, which is negative, an electron, which is also negative, that's why it shows up as positive. Okay? So anytime you see a positive, it means you lost an electron. Every time you see a negative, it means you gained negatives. You gained an electron. Okay? So let's draw Li. And let's draw Cl. And let's look up how many valence electrons are in Li. Lithium is right there. 1. It only has 1. Cl, I mean, we could look at this one, or we could look right here. Cl is, where are you? Cl right there, 7. Okay? 1, 2, 3, 4, 5, 6, 7. All right, so that's simple. We're going to bring this valence electron here, and what we end up getting is, I'm going to put it in brackets. So Li, because it lost, Li lost an electron, it's going to be positive. And chlorine, because it gained an electron and it's got a full octet, it's going to be negative. Now, here's the thing. This is actually not a very strong bond in water. Let me clarify that, because I went online and there's a huge argument where there's people saying that technically ionic bonds are stronger than covalent. These are ionic bonds. This is covalent. Now, technically that is true. These are very, very strong bonds, but when you put them in water, it's game over. Water dissolves it. These are salts. And because water has both positive and negative charges, it could easily break this apart. So when you put lithium chloride in water, it breaks apart. Yeah, this is like putting a magnet on a refrigerator. You could pull it apart easily. So we'll describe later next week the difference between ionic bonds and covalent bonds. You know, ionic bonds have bonds between positives, cations, and anions, negatives, positive, negatives, and covalent bonds are different. There's no positive or negative charge. The whole thing might be negative, but these bonds are pretty strong. There's a slight little difference. Let me show you one more. I'm going to do one more because this one, let's be honest, it's like this one right here. It wasn't very challenging. So let's look at magnesium. Magnesium and oxygen. Magnesium has 2. Oxygen has 6. Right here. 1, 2, 3, 4, 5, 6. All right. So we could put 1 valence electron there and 1 there. So here's the answer. I'm going to put a bracket. Magnesium. Now, how many electrons did it lose? It lost 2 of them. So it's going to be positive because it lost electrons, but it's going to be 2 positive. Okay, because it lost 2 of them. Now notice how I wrote 2 positive. It's not, you do not write this. This is completely, you do not write Mg positive 2. It's not written like that. Okay, you find that in mathematics, in the number line, positive 2 or negative 2. In chemistry, it's 2 positives. That means, 2 times this happened. Positive means it lost an electron. Now we're going to write oxygen in a bracket. Put oxygen. It has its full octet. 1, 2, 3, 4, 5, 6, 7, 8. How many electrons did it gain? It gained electrons, so it's negative, but it gained 2 negative. So 2 positive and 2 negative cancel out. Again, you do not write oxygen negative 2. This is wrong and that's wrong. It's written 2 positive and 2 negative, not positive 2, negative 2. Okay, that's how it's done in math. In math, you might have positive 2, times negative 3 or whatever. But in chemistry, the positive and negative sign is written afterward, okay, because that represents losing an electron or gaining an electron. Okay, and there's other problems, you know, underneath that. I did the first 2 with you, and you only have to do 8. This is if you're in honors. If you're not in honors, you can challenge yourself to do that. All right, anyways, if you have any questions, see me during office hours, Tuesday and Thursday from 8:30 to 9:30. Have this ready. Tell me which page you have trouble with, what number, and we'll work on it online. Other than that, this is due the following Sunday that's coming up at midnight. You have to take a picture or scan it and email it to me. You have to have all the worksheets done to get credit. All right, take care. See you soon.